Okay, so for this problem, we need to evaluate this limit right here and give a graphical interpretation for that limit. Alright, so let's go ahead and write this down. The limit as x approaches 2 of x cubed minus x squared plus 5. Okay, that polynomial right there. Now, as a first step, we need to realize that we may be able to take advantage of continuity. Continuity can make evaluating limits very, very easy. Okay? If you recall, if a function is continuous at a given value, in this case that value might be 2, okay, then that means that the value of the function at that c value, 2 in this case, and the limit as x approaches that c value, both exist and agree in value. So if you're after the value of the limit, you can simply find the value of the function, provided it's continuous. Okay? So, in looking at this function right here, the function x cubed minus x squared plus 5, well, what kind of function is that? That's a polynomial function. And one thing we know about polynomial functions is they're continuous everywhere, which means in particular they're continuous, this one here is continuous at 2. That makes the job of evaluating this limit really, really easy. All we have to do is evaluate this function at 2. In other words, plug it in. So this is 2 cubed minus 2 squared plus 5. That's 8 minus 4 plus 5, which is then 9. And that's the value of the limit. Okay? Now, as for our graphical interpretation, keep in mind we evaluated this limit by plugging it in because we knew we were dealing with a continuous function. A function that was continuous in particular at x equals 2. So our graphical interpretation here is we're looking at a point of continuity at, and we could say at x equals 2 here, but we've gone to the trouble of evaluating the limit. Remember, the limit gives us the height or a height of a function, or at least an expected height of a function. It is a y-coordinate, and so we can say this point of continuity is at 2, 9. Okay? So that's the graphical interpretation. All right? Graphically speaking, if we were to draw a piece of this graph, we won't draw the whole thing, but that means if we go over here to 2 and we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, here's a point here, okay? That point is on the graph of y equals x cubed minus x squared plus 5, and if we looked immediately to the left and to the right of this thing, we would see the function is attached. Now, I don't know if it's increasing or decreasing or going down and coming up. I don't have that available to me. I would need to do a little more analysis to figure that out. But essentially, this is what the function looks like right around x equals 2. Okay? So there's the value, and there's the graphical interpretation, and we're done.